Hello everyone. Today we are going to talk about scalars and vectors. In physics, we can classify the quantities as scalars and vectors. What is a scalar quantity or what is a scalar? Scalar quantity is a quantity with magnitude only. A scalar quantity is specified completely by a single number along with a proper unit. The number along with the unit is the magnitude of that quantity. For example, consider these 2 points A and B. When we measure the distance between these 2 points, let me get it as 10 meters. Okay, let the distance between these 2 points as 10 meters. I'm simply taking one number here, 10. Okay, so here the quantity distance, it has a number with a proper unit. So to specify this quantity distance, we don't want to talk about the direction. So distance has a magnitude. This number along with the unit, that is actually called as magnitude of the scalar quantity. Okay, distance is a scalar quantity. Okay, so scalar quantity is a quantity which is specified completely by a single number along with a proper unit. Okay, we don't want to talk about the direction of that quantity. That quantity, there won't be any importance for the direction in the case of a scalar quantity. So distance is a scalar quantity. It is completely specified by a number along with a unit. Alright, similarly, mass of an object, then temperature of a body, then time at which a certain event has happened are examples of scalar quantities. Alright, now how do we add two ordinary numbers? For example, consider two ordinary numbers 2 and 3. How do we add these two ordinary numbers? We will get 2 plus 3 is equal to 5. Right. Now, how do we multiply two numbers, two ordinary numbers? For example, 2 and 3 again. So, you will get 2 into 3 equal to 6. Right. The scalar quantities can also be added, subtracted, multiplied and divided just as the ordinary numbers. But addition and subtraction of scalars make sense only for quantities with the same units. That is, we can add two lengths. For example, 10 meters plus 20 meters. Okay, we can add two lengths. Lengths are scalar quantities. Okay, length is a scalar quantity. So, we can add two lengths and you will get the result as 30 meters here. Okay, and we can subtract two masses now. For example, 20 kilogram minus 10 kilogram is equal to 10 kilogram. So, we can subtract two masses. Right. So, we can add two lengths. We can subtract two masses. But we cannot add a scalar quantity. We cannot add scalar quantities with the different units. Here you see we added two lengths. So, both the lengths are scalar quantities with the same unit, meter. Okay, here we have added masses. Both are having the same unit, kilogram. Okay, but we cannot add scalar quantities with the different units. For example, we cannot add mass with a length. For example, 20 kilogram plus 10 meters is equal to what? It is not possible, no? Because we cannot add mass with a length. Right. Similarly, we cannot subtract temperature from mass. For example, 10 kilogram minus 1 degree Celsius. What is the answer? It is not possible because we cannot subtract temperature from mass. So, addition and subtraction of scalars make sense only for quantities with the same units. Meter, kilogram, like that. Okay, addition and subtraction of scalars make sense only for quantities with the same units. If the units are different, okay, it is not possible here. But, however, we can multiply and divide scalars of different units. For example, to get the density of an object, we will divide. I am representing density by capital letter D. Then density, to get the density, we will divide mass with the volume. No, that is mass divided by volume. Alright, for example, you just take the mass of an object as 10 kilogram and volume as 2 meter cube. So, what will be the result? 10 by 2 is 5 kilogram per meter cube or kilogram meter raised to minus 3. Okay, so here mass has a unit kilogram, velocity has the unit meter cube. So, both are having different units, but division is possible. Okay, so we can divide the scalars of different units. We cannot add or we cannot subtract the scalars with the different units, but we can divide the scalars with the different units. Alright, Now, to get the distance traveled by an object, in the case of a car, okay, moving car, we have the expression like this. Now, distance is equal to speed into time. Okay, let the speed of that car be 10 meter per second and let the time taken as 5 seconds. Okay, so what will be the result? 10 into 5, 50. Then the second from the denominator can be cancelled. So meter. So distance traveled by the car is actually what? 50 meters. So here we have multiplied two scalars. Speed is a scalar quantity. Time is also a scalar quantity. So here we have multiplied two scalars with the different units. One is having a unit of meter per second. Another one has the unit second. Okay, so we can multiply and divide scalars of different units, but we cannot add and subtract scalars with different units. So addition and subtraction of scalars makes sense only for quantities with the same units. Okay. Now, what is a vector quantity? A vector quantity is a quantity which has both magnitude and direction and obeys triangle law of vector addition or equivalently the parallelogram law of addition. A vector quantity is specified by a number along with a proper unit and its direction. So direction has an importance here in the case of a vector quantity. So vector quantity, it has both magnitude and direction. It will have a number along with a proper unit, then direction. Okay, we will discuss about the triangle law of vector addition and parallelogram law of addition in the coming videos. I will provide the link in the description box so that you can watch at that time. Okay, now the displacement of an object or displacement, then velocity, acceleration, okay, force, etc. are examples of vector quantities. A vector, it is often represented by an arrow placed over a letter. Okay, for example, we can use a bold face of that letter. That is also, that is also okay with that. For example, force is a vector quantity. So it can be represented by F, then here a vector, arrow mark over this letter F. So vector F. This is a vector. Force is a vector. It can be represented like this. Okay, or instead of putting this arrow mark over the letter F, you can just bold this letter F. Okay, either you can take this representation or this way of representation. We often use this representation, vector F. That is an arrow sign over the letter. Okay, now the magnitude of a vector, that is often called as its absolute value. Magnitude of a vector, that is actually called as its absolute value. For example, velocity is a vector quantity. So magnitude of that velocity is a vector quantity, so that can be represented like this, vector v. Then magnitude means I am taking the modulus, that is I am taking the absolute value. Okay, absolute value is indicated like this. Alright, so this will be equal to what? That is magnitude of a vector, that is actually called as its absolute value. So to find out the magnitude, we just want to take the modulus here. Then we will get the magnitude only v. So v is the magnitude of the velocity and vector v is the velocity vector. So vector v has both magnitude and direction. But v, when we take the magnitude only, then we don't want to talk about the direction. It has only a magnitude. Alright. So in this video, we have actually talked about scalars and vectors, the basic ideas of scalars and vectors and a few examples for these two. I hope you understood this. Thank you.